Let's discuss about the data structure. So data structure is how efficiently you are storing a data in a particular order, okay, or in a particular structure. So this is actually a data structure. So let's consider one scenario. There is a array list data structure, because this is also a type of data structure. So in array, you are storing a value. So suppose in 0 index you are storing 1, and 1 index you are storing 2, and 2 index you are storing 3, and 3 index you are storing 4. Okay, so in each of this index you are storing a value, something like this. So friends, what will happen if someone will say that, hey, insert a data at the position of index 1, then what you will do? Insert a data, let's say 5, then what you will do? What about the other element which is already there in that particular index? Suppose that in index 2 the value is 3 is there, but if you will insert the data at the index of the 1, which is the 5, then other data will start shifting. You have to shift the position. Each of this element will be shifted with one index. Okay, so it means what? It means it is a cost. It will take some time to shift the data. It will consume some resource. You might say that there it maybe it will take some time, but time is very minimum, very low, and in microseconds, something like that. So friends, actually this small fragment of time can cause a big issue. It will it will create a big impact in your application. Why? Because this type of lots of operation is going on. Then of course, uh, if a little bit this time will, if you try to count, then it will take more time. So this is not a optimized way to do that. If you want to insert a data in array, then you have to shift. You also wonder that you never shift, you just use the inbuilt method, and inbuilt method already doing these things for you. But internally, every, because this is a very basic use case to insert a data, since this is a general use case, that's why in most of the programming languages you will find this type of method, inbuilt method to insert a data in a particular position in array list. But actually internally they are doing the same thing. They are shifting the other element by one index, or maybe depend upon how many data you are storing and where you are storing. So suppose you will store 5 or 2, then the other element 5, or let's say 7, then other element will be shifted by 2 index. Okay, so there is a time complexity, it will take some time. So actually this is not efficient way. So if there is a operation in your like application, if you want to do certain operation where the you want to store a data at the beginning of this array, if this is a requirement, then it will be very difficult, and it is not a optimized way to design your application using the array list data structure. Okay, so you have to follow some other data structure. Now let's consider a scenario of the linked list. But wait, I will come to that. Suppose if someone will say that, hey, I need a data. Suppose that at the index of the 2 you need a data, then in that case in index of 2 you will get a data. You pick the data very easily. So there is an advantage as well. In array there is an advantage that you can easily pick the data from any particular index. There is no need to check each of this element for picking the data. But again, if you are inserting a data, then other element will be shifted, and other element will again uh, will be, you have to rearrange. other element. So that's why there is a time complexity of big O of n. Again, I will talk about the time complexity uh, in the upcoming video, but uh, I hope that you have a little bit idea that big if there will be one loop, just for a like, as a general, if there will be one loop, if you are checking each of this element, then you can say it's a big O of n. And if you are picking one particular element, then you can say a time complexity big O of 1. Okay, big O of n means you are you are trying to access each of this element. Means how you will do, basically you will do through the loop. If there is a one loop, then this time complexity will be big O of n. Okay, so what will happen, let's try to understand the time complexity in the array data structure. So suppose if you will there is a three condition, there is a three scenario. If you want to insert or delete a data from the beginning, if you want to insert a data at the end of this array, or if you want to insert or delete a data at the middle or any position, so what will be the time complexity? So if you want to add or insert a data at the beginning, so let's say time complexity, okay, time complexity, so the time complexity for getting a data, let's say start with the getting a data, get time complexity cost. So for the getting a data, the time complexity will be the big O of 1. Again, I will talk about in the upcoming video how to calculate a time complexity, but here you can say you are picking data at any of this position, any particular position, then it's a big O of 1. Okay, and then the time complexity for insert or update, for insert at beginning. Insert of the beginning, it beginning may, if you will insert in the beginning, then it will be big O of n. Why? Because the shifting will be happen for each of this element, so that's why the big O of n. Again, insert or delete, in both of the cases, let's say insert or delete. Similarly, time complexity for deleting a data, sorry, time complexity inserting at the last. So inserting or deleting a data at last, the complexity will be big of 1, because you easily you can find out the last index, and adding or removing the element from the last index is very easy. Okay, on big of 1 it will take the time complexity, because you just you will insert at the last, and no need to check the other element. Okay, similarly, but yes, if you will do for the middle of this element, or then again the time complexity will be big of n. Why? Because maybe there is a constant, like if you will add in exactly middle of the element, then you can say n by 2. But again, uh, generally if you are talking about the big of n, then n represent n number of data, which is the, it's a very huge data, suppose at 1 lakh, 1 crore, something like that. So if you will insert at the middle, then the time complexity will be big O of n. So again, if you will notice, the time complexity for inserting a data in a data list, then the complexity is big O of n. But getting a data from any particular position is very easy. You can get with the uh, with the time complexity cost big O of 1. But let's talk about the link list. Okay, so in the link list, generally data will be stored like this, that this will there is a no index concept here. The data will be stored like value. This is the value 1, and the next value, you are targeting the next value. Okay, so you are storing the address of the next value. So next represent the next value, so next value is 5, and again, after the 5, what will be the next value? You are uh, saying that next value will be 2, and again, what will be the address of the next link with the next? Then it will be 3, and so on, and at the last it will be null. Okay, it means what? If you will try to understand with this diagram, then easily you will understand. So in the linked list, 77, suppose that 77, 44, AA and C. So 77 is stored. Okay, 77 is stored, and the next data will be linked. It means the next address will be stored here, that the next data will be 44, and again the next data will be AA, and again the next data will be C. So this information is already also stored. So in this scenario, and at the last, the value will be null, the next data, the address will be null. Okay, because there is no more data. So here you can, if you will try to understand, then what will happen? So they are just targeting, also storing the value of the next data in the link list. So it means there is a one link, and all the link is attached. Okay, so let's talk about the time complexity in this case. If there is a scenario, if you want to store a data at the beginning, then what you have to do? If you store a data at the beginning, so it is very easy. So let's try to understand. Insert or delete a data at the beginning, then what you have to do? It is very easy. Why? Because you just need to, you value is already there, you have to just store the target, means next data, to this one. Okay, it means what? If you want to store any data at the beginning, then you just need to target or provide the address of the next link. So in that case, what will happen? If you want to store a data in the beginning, then suppose let's say here is a value you want to store a 10, and the next data you just need to point the next is this one. That's it. You done these things. It's very easy. So just format this. So you can say that you easily store a next data, just you need to appoint the next data. That's it. So insertion is very easy. The time complexity of insertion and deletion at the beginning is a big O of 1. But again, if you want to get a particular data, then how you will get it? How you will access a data? What will be the time complexity cost? So if you want to access any data in the linked list, then you have to check from the beginning. You have to check, suppose you want to find out the 2, then how you will do? You will check the 10, then you will go to the next data, you will check the 1, then you will go to the 5, and then you will check the 2, and you find that yes, 2 is matching, you want 2, and in this way you will get it. So the time complexity cost for getting a data is a big O of n, because it will try to check each of this element, each of this link. Okay, to get a particular data. So time complexity cost for accessing any particular data will be big of n in the linked list. So again, this is if you want to uh, access any particular data, if you want to find out any particular data, then the time complexity cost is huge. So but inserting a data is very easy in the linked list. You can easily insert a data, so the because time complexity will be just a big of 1. Again, inserting a data at any places is very easy. Okay, just you have to point the address of the next data, that's it. You just have to do this simple thing. But again, what will be the time complexity if you will uh, insert or delete a data at the last. Okay, in the last, if you insert a data, then that time complexity will be big O of n. But you will say, why big O of n? Because for inserting the data at the last, first and foremost you have to get a last element. How you will get a last element? If you will get a last element, then their complexity will be big O of n. After getting a last element, then only you can insert or delete uh, at the last. So that's why the time complexity of the last index will be big O of n. Similarly, if you want to insert or delete uh, a particular element in the linked list uh, at the middle, then what you have to do? Again, you have to first and foremost you have to find out that element. Means after that element you want to store a particular data, and then you have to just link the next element. Okay, so suppose if you want to store a particular value after the 5, then then what will happen? The next value next will be point to what you want to store, and there next will be point out to 2. So very easily you can insert, but but before that you have to find a particular value, then only you can do you can insert at the middle. So that's why the time complexity will be big of n, because first and foremost you have to find out a particular element, then only you can insert. But generally inserting a particular element in linked list is time complexity is big of 1. So insertion is very easy here, but accessing a particular element is very tough. It's not tough, but the cost of the time complexity is high. So if you are creating a data structure for your project, so you have to think all these things, and based on that you can decide which one will be suit for your particular feature or particular project. So I hope you understand. If you will face any problem related to this, then please comment. Thank you.